5 types of the veins. They go from that very small, which would be the areas at that capillary bed, to the very large, which are my vena cava, that empty into the right side of the heart. We're going to find we have our post-capillary, post-after, okay? They're the smallest. They are receiving the blood from the capillaries. They are porous, meaning they have the ability, because they're 1 cell layer thick, okay, for exchange, and this allows for exchange with surrounding tissues at that tissue level where we need it, not only for something to move out, but for something to move in. Then we go from the smallest up to what they call muscular. That's the one that starts after the post-capillary. From muscular, we go to medium. At medium, we're going to see a little more material showing up. We're going to see a basement membrane. We're going to see some connective tissue. We might see some elastic lamina, meaning some of that tissue showing up to make it a little bit thicker. Oh, that's supposed to say valves. All right, that's a typo. And at this point, in medium, we begin to see what they call valves. So if you're looking at a vein that's going to be medium in size, they're going to have this structure, valves. Their job, direct the blood flow. Make sure there is one-way blood flow to the heart. So if you think about from your big toe, because your big toe gets blood supply, it has the capillary beds, and from your big toe, or the second toe, whichever one's the longest, okay, maybe the third, I don't know, okay, but from that point, all right, think of it this way. Arteries have, for the most part, they get to have gravity work with them. At the point for the veins, gravity is working against them. They're not pulsatile, so they don't have the pressure. We've got to make sure the blood flow comes back to the heart. How are we going to do that if I don't have any pressure, I don't have any pulsatile, okay? So these valves, they're going to be located throughout these medium to larger veins, and they're going to help direct the blood flow. So that if, now, don't know if y'all know this, but for movement of venous blood, we are dependent on skeletal muscle. So when you walk, you get to move, create that push against the veins of the big toe, going into the leg, coming up into the abdominal pelvic area, making its way back to the vena cava as you move. And you get to help push the blood. So if you're moving and you push the blood, that valve will open and the blood will get to flow, and then once you've stopped, it'll close so that that blood flow doesn't go from here back. But we know that these valves fail. How do I know that? Get this ugly vein that's going to start popping out. Look all ugly. People are going to go to the doctor and they're going to be like, dude, that thing is so ugly. And, oh, it hurts a little bit. What can I do? Well, you've developed Anybody know what it's called? Because it went out of my head. That's why I was asking y'all. The varicose vein. Okay. All right. And the doctor's going to be like, well, I can send you to a vascular surgeon. Y'all ever known somebody who had the surgery done on their varicose veins?
She said it was like it sounded painful. I don't know. She said that they're gonna like go in and yeah, it sounded really abrasive. I don't know.
It is. It is. And one of the things that I kind of, which I mean, people do it all the time, but basically they are directing the blood flow in a different direction. That vein they kind of bypass that vein now, which is like really odd to me. But anyway, but people get them fixed and they can usually do okay, but I guess you just have to weigh the good with the bad. So we're going to go from medium to what's going to be called venous sinuses, meaning some capacity, some area, okay? The walls are going to be thin, lumens are going to be large. We don't have any smooth muscle that's going to be present. Do you guys remember, for example, the coronary sinus, which was part of my coronary blood flow? All right? And the blood kind of came back to that sinus until the heart contracted, and then it moved into the right atria. Okay? We're going to find in the brain, due to the special circulation of the brain, and that's what they call it. They call it a special circulatory route. It goes into something called dural sinuses. Do you guys remember the dura mater, pia mater? Okay, that means it's going to be this little area within the dura of the brain. This means there is no constriction that occurs in these areas. Okay, the blood is going to be dependent on something else pushing it completely. In the largest veins, we're going to have our smooth muscle, and we're going to make our way back to the right atria of the heart. In some areas of the body, the structure that we get between arteries and veins, it's going to give us special circulatory routes, meaning they're going to occur in certain areas, and for some of them, the route can occur based on exterior circumstances around us, meaning what is going on in the environment around us. One of the special circulatory routes for the blood flow. Do you guys remember us talking about a portal system? Do you remember us mentioning a portal system? Mitzi, do you remember where it was?
It's in
We've got a special portal system that we mentioned in our endocrine system. Do you guys remember the hypothalamo? Do y'all remember all that? All right. That was where that portal system, you have blood flow come in, reaches a capillary bed, and it'll go to a second capillary bed before it enters back to the bloodstream. So we had that capillary portion in the in our hypothalamus, and then we had the second capillary bed in the anterior pituitary, and so the blood flow went from that first capillary area to the second capillary area before entering back into the bloodstream. That's a portal system. You have two. You have that one, and then you're going to have one with the liver. Okay, the hepatic Anytime you hear hepatic, that means liver. You have a hepatic portal system. So, when we're looking at blood flow, as they're showing, the simplest blood flow is where it occurs throughout the majority of the body, leaves the heart, goes to the capillary bed, comes back to the heart. That's our simplest, okay? But that portal system, it went to the first capillary bed, to the second capillary bed, before it enters back into the bloodstream. When we have this blood flow, arteriovenous, arteries, veins, anastomosis, anastomose means you put something together, okay? It's like you build something together. We kind of hear this maybe referred to as a shunt, okay? So, basically, when we look at this, blood flows from that artery side, the artery, directly to the vein. Meaning, when we have this occur, rather than blood flow going to that capillary bed, it'll bypass it altogether. We have these in fingers, toes, ears, nose, lips. This is because when there is an exterior environment, meaning you're in 50-degree below zero weather, all right? The last thing that your body is going to care about feeding the blood flow to, which is warm, okay? Feeding the blood flow to is anything to this exterior part, okay? It's going to keep that blood as much as possible within the core. And it's like, I don't care if these fingers, freeze and fall off, or if the nose freezes and falls off, or if the ears freeze and fall off. The body doesn't really care. It's called frostbite, okay? Because it's going to shunt the blood flow back to the core. All right, it's almost like it says, forget the extremities altogether. We can have just a venous anastomosis. This is where a vein empties directly to another vein. Now, what this allows for is just an alternate route of drainage. It's not that it's very common, okay? It can happen with some of the organs of the body in times of need, but that's not going to, really be that much of an issue. We can have an arterial anastomosis where it goes from an artery to an artery, all right? And by, basically not going to the veins just yet. A good example of that would be our coronary circulation. As the blood moves into the tissues of the heart and then makes its way back to one of those sinuses, the coronary sinus. So these are what they term alternate blood flows. These are ways that the blood can flow if needed. Right now, under these normal circumstances, we're getting the blood flow to our fingers, to our ears, to our nose, whatever the case might be. When we talk about the circulation that's going to occur, well, yes, blood, they do, you will hear people refer to it as the life fluid, because that's what it does, keeps us alive, okay? But we have to have control, okay? We've got to have control at the level of the heart itself, we've got to have control within